All right, geometric sequences. This is the other type of sequence that you're going to find in the unit. Quick reminder, arithmetic sequences, those had a common difference between each number, so if you took a number and subtracted the one before it, you'd find your difference. For geometric, we have a common ratio, so the operation that means is division. So we're going to take a term, and if you divide it by the one before it, you'll find your common ratio. And then we have a formula for geometric mean as well. Okay, so for problem 1, again, this is just going over the vocab for you. Again, if problem 1, if you want to know if it's geometric, you're going to take each number and divide it by the one in front. So 48 divided by 24, I get 2. 24 divided by 12, we get 2 again. 12 divided by 6, you'll get a 2, and 6 divided by 3, you get a 2. So that confirms that this sequence is geometric. When you're identifying sequences, you want to know the first term, which in this case is 3, and then we use the symbol R for our common ratio. Okay, we'll try the next set of numbers. 15 divided by 12. 12 divided by 9, 9 divided by 6, and 6 divided by 3. All right, notice I've gotten a different number each time, so this would be not geometric. Okay. And then our last one, don't let the exponents throw you off, they're still just numbers. So you've got 3 to the 20 divided by 3 to the 15. Okay, we get 243. Then 3 to the 15 divided by 3 to the 10. Okay, get 243 again. And then 3 to the 10 divided by 3 to the 5. Get 243. So this is also a geometric sequence. Okay, your first term is 3 to the 5, and your common ratio is 243. Which is also the same thing as 3 to the 5. Questions for you to try. All right, problem 2. So what are the indicated terms of the geometric sequence? They want to know the 10th term. So they have already told us it's geometric, so then we know it's going to follow our formulas. Those are on your formula sheet. All right, and so our geometric sequence, it gives you the definition again. They have a common ratio, and then telling you what each of the terms are. So A1 is your first term, there's your recursive formula, and here's our explicit formula. So if this is geometric, we need to find that common ratio. Again, we'll find that by dividing each number by the one in front of it. So 36 divided by 12, we get 3. 12 divided by 4, we get 3. So this is geometric. Our first term is 4, and our common ratio is 3. So to find our explicit formula, any term you're looking for is the first term multiplied by r raised to your previous, your term number minus 1. So if I want the 10th term, it would be our first term, which is 4, r, which is 3, and then it's going to be 10 minus 1. 10 minus 1 is 9. Order of operations, we do exponents first. So 3 to the 9. And then last step, we times by 4. So our 10th term is going to be 78,732. For the second part, they want to know what the second and third term are for this sequence. So here, you know the known information is the first term and you know the fourth term, but we're missing r. So we know A1 is 2, a to the 1, 2, 3, 4 is negative 54. Okay, we have our explicit formula. If you substitute what you know, a to the 4 is negative 54 is going to be 2 times r to the 4 minus 1. Negative 54 equals 2r to the 3. Divide both sides by 2. negative 27 equals r cubed. To solve for r, we take the cube root, math, cube root of negative 27. Okay, and so negative 3 equals r. Now that we know what r is, you can go back to your equation. A to the n is a to the 1, r n minus 1. So a to the 2 is going to be 2 times negative 3, 2 minus 1. So you should get 2 minus 1 is 1, negative 3 to the 1 is negative 3, times 2 is negative 6. Or you could just do negative 54, divide by negative 3, get 18, divide by negative 3 again, get negative 6, working backwards this way. All right, now you are going to see a question like this bouncing ball problem on your assessments. It says when a ball bounces, the heights of consecutive bounces form a geometric sequence. Okay, what are the heights of the fourth and fifth bounces? So we start with A1, it's 100, and this is the second bounce, this is the third one. Here's the fourth, and they're going to want us to find the fifth as well. So this is it's in the context of a word problem, but it's the same math we just did. You know A3 is 49. First one was 100. So if we solve for R, then take the square root. Okay, so they get 0.7 equals R. They've left that as a fraction, so 0.7, same thing as 7/10. But now we know R and we know A1, our first term, so now we have what we need to find any term. So they wanted the fourth and fifth bounce. So a to the 4 is going to be 100 times 0.7 to the 4 minus 1. Okay, and then the next term, a to the 5, you could do the same thing, 100 times 0.7, but it's 5 minus 1. Okay, so that you have your heights that you were looking for. All right, now the geometric mean is when you're looking for a missing number. Okay, the square of the middle term of any 3 consecutive numbers is equal to the product of the other 2 terms. So they give you the formula here, the geometric mean of 2 positive numbers. So if you want to find the geometric mean, it's going to be equal to the square root of x times y. That one I don't believe is on your formula sheet, so you can add it to it. You want to write it in at the bottom. Arithmetic mean is going to be the square root of x times y. So for this one, the geometric mean would be the square root of 48 times 3. Okay, so it's going to be 12. And then we have to include the positive and the negative because if we do, either one will work. If you do 48 and then positive 12 and 3, it'll have the same common ratio. And then if you also did 48, negative 12 and 3, it's going to give you the same common ratio. Okay, and then there's one for you to try. Some extra practice. but be sure to add this to your formula sheet so that you can use it for your assessments.